Welcome to the Heresite webinar, HVAC coatings in a changing world. Thank you so much for joining us this afternoon. We feel very fortunate. We've got folks from all over the world joining us. So we're very thankful that you take the time out of your day to spend some time with us. A couple of introductions before we get going. I'd like to introduce Dan Lusk, who'll be our presenter this afternoon. Dan's a sales manager at Heresite. And then also joining Dan is Kayla Oldrich, who's the sales and marketing manager for Heresite. So you'll hear from Kayla throughout the presentation as well. Just a couple housekeeping items. Please mute your microphone. I have everyone set to mute, so it shouldn't be an issue, but just make sure your microphone is muted. The webinar will be recorded, and we'll be sending out a copy to all participants, and you can share it with your teams. As far as questions, we are going to use the chat feature to submit questions, and we'll answer it as many as we can at the end of the presentation. If we don't get to your question, we'll more than likely probably send out a Q&A document to everyone as well. And then Dan's contact information, email address, and contact info will be included on the last slide of the presentation. So feel free to reach out to Dan with any specific questions or inquiries. The presentation should last probably about 20 to 30 minutes, and then we'll be happy to answer any questions. So with that, I'm going to turn it over to Dan.
Great, Jeff. Thank you very much. Like Jeff said, I'm Dan Lusk. I'm bringing my 40 years of experience in coatings today to talk to you about Heresite, tell you a little bit about who we are, the unique things about our coatings, and then talk about how our coatings have changed and what's changing in the world today and how we're adapting to that. So thank you all for joining us. We were founded in 1935. Our founder, Charles Hempel, was an expert in phenolic coatings and phenolic resins, which was new at the time. In the 1960s, we invented the process of coating HVAC equipment with thin film high performance coatings. We're now in over 40 countries throughout the world. If you see on the right, the photo there, that's a picture of our plant back in the 1930s. We still work out of that same facility, so there's a lot of history there. We have certified applicators. Those are painting companies that specialize in coating coils throughout the world, that do a terrific job in applying both our baked finishes and our air dry finishes. And we're proud to be known as the performance leader in HVAC coatings. When people want the best, they come to Heresite. We have two main topics, divisions in our company. We deal with both industrial or chemical environments, very difficult environments. And we also deal in commercial or coastal environments, salt air environments. Our coatings are made for both of these. Deciding which coating to use will be discussed today in the presentation. So the basic thing we do is we extend the life of heat exchangers and we fight corrosion, mostly on aluminum and copper. And like I said, from both salt air and chemical exposure. And we increase the long-term efficiency of the heat exchangers. So the basic thing that we try to prevent is the corrosion cell. It's a condition on a metal surface where an electric flow or a current occurs, and it's a degradation of the metal. So what we try to do is take one of four things away: either the anode, the cathode, the metallic pathway, and an electrolyte. If you take any of those four things away from a corrosion cell, the corrosion stops. And we eliminate the metallic pathway by keeping the electrolyte away from the metal by using a coating. There are a few different types of corrosion in particular we deal with. The first is called galvanic corrosion. This is an electrochemical, again, process where metal corrodes when there are two different types of metals together. There are some metals that are more nobler or more cathodic than other metals. So those metals will perform better in a galvanic situation. For instance, a more nobler metal in what we do is copper. So if there's aluminum and copper touching each other in a corrosion cell, the aluminum will sacrifice itself to the copper and it will corrode or deteriorate. So what we do with a coating is keep that aluminum and copper apart so there's no galvanic corrosion. We also deal with formicary corrosion. This is a corrosion that happens with copper. Both oxygen, water, and organic acids combine and create what's also called pinhole corrosion. So if you have a copper tube that has a hole in it, it has a leak in it, it's usually due to a formicary corrosion. So it's important to note that HVAC coatings are unique. They have to do a number of different things. First of all, they have to adhere to bare metal without a primer. Again, usually it's copper and aluminum. And they go on very thin. They go on 1 to 1.5 mils dry film thickness, which is about 25 to 40 microns. And they have to perform and have maximum corrosion resistance in being on so thin. And the reason they go on so thin is to minimize heat transfer loss, so that you get the same performance of the heat exchanger with the coating on and without. So there's less than 1% heat transfer loss in using our coatings and protecting a heat exchanger. So really, these coatings have to do a lot in both marine coastal environments, in corrosive chemical environments, in temperature extremes, and both with humidity and with immersion. And really have to do a lot for a thin film flexible coating that goes on very thin. But with us, it all starts with research and development. We have a long history with OEM coil manufacturers, having done this since the 1960s and understand the needs of the market. We have 30 to 40 years of test data, the most extensive test data in the industry. Much of that is on our technical data sheets. We also have specifications, and we have a chemical resistance guide that's 29 pages long that deals with a number of different chemicals and how our products perform in those environments. And lately, we have extensive test data on our new generation of products and how they perform in different environments. So most of our competitors and most paint companies take their coatings and they send them out to third-party testing. Much of our testing is done in-house. We have very sophisticated equipment, from a salt chamber to really looking at UV testing, chemical testing, that we all do in-house. And this leads us down the path of being the leader in performance when it comes to HVAC coatings. So lately, our research and development has turned to our changing world. And that's a world that's demanding higher performing products, things that are sustainable in our environment. And really, we're looking at leveraging new technology. So we have two basic types of solutions. And one is our baked coatings. This is coating that's applied and cured by baking in an oven. It's for the most difficult environments, both C5M offshore corrosive marine environments and severe chemical environments. These products are superior in performance to other products on the market. Our air dry coatings are spray applied, and they just dry in the air. And they are ideal for coastal marine environments and mild to medium chemical environments. So our baked phenolic resin, again, it's a convertible coating where it's baked in an oven. And it's a very dense cross-linking material. So if you look at the left side of the screen, you'll see the molecules when it's air dried. And then on the right side, you'll see how those molecules really come together and cross-link when it's heat cured and put in an oven. The corrosion resistance leader in HVAC equipment is our P413 baked phenolic coating. This really is the industry standard in performance for, again, both chemical and marine environments. It has the most extensive test data of any HVAC coating. Some of the typical tests that we do is an industry standard test, which is the ASTM B117 salt spray test. And this has over 20,000 hours. We have a cyclical testing, which is a more real-world test that this passes at 4,200 hours. And we have 18 other tests that are shown on our technical data sheet. We also have air dry coatings. So when we have this superior performing product that's baked on, why would you want an air dry coating? Well, It's less expensive. It's expensive to apply, and there's less equipment needed for application. So it's easier to apply. But there's a cost to that, and that is there's a serious reduction in corrosion resistance performance. And there's limitations on the environments that it can withstand as far as chemical environments. So while air dry coatings are easier to apply, you don't need an oven to do it. There's a significant difference in performance. So there's a trade-off. Our most popular air dry product is our VR514 air dry phenolic. We innovated the product some 40, 50 years ago. Again, it's sprayed on and you let it dry. There's no baking that's needed. While it does have a cross-linking mechanism to it, there's a serious reduction in cross-linking compared to the P413 baked on finish. So there's a trade-off in performance, but very easy to apply and used all over the world in various applications. So those are the two basic products we've had for a number of years, but our world is changing and people are demanding more sustainable products. Our environments are changing with global warming. Coastal populations continue to increase as more and more people are moving from inland to the coast. Our customers are more demanding than they've ever been, especially with inflation that's happened since COVID. And a return on investment is even more important than people today. So we've introduced our HereShield technology. It's an innovation that we started 7 years ago in development. It's an acrylic resin that's water-based, a significant reduction in VOCs, environmentally friendly. It has excellent corrosion resistance and superior to solvent-based finishes. It is both QUV resistant and UVC resistant. And that's more important now where hospitals and healthcare are using UV machines to kill microbes and that in the air. And as far as adhesion goes, it's superior in bare metal situations. So a conventional acrylic resin cures by what's called coalescence. That's how the molecules come together. They pretty much melt together. That's advantageous in a lot of situations, especially in exterior house paints. But just having that as a curing mechanism is not advantageous in the HVAC industry. So we have a unique waterborne resin that combines the coalescence of an acrylic and the cross-linking that happens in our other coatings. It's a proprietary resin that we've developed that offers all the advantages of a water-based low VOC product, but really the dense film and the cross-linking of a conventional paint. So both of these lead this product to be our highest performing, the performance leader when it comes to air dry HVAC coatings. So it's ideal for a marine environments. We have extensive salt air testing, both real world and in the laboratory. The ASTM B117 salt spray hours on this are 15,000 plus hours. That's compared to under 5,000 hours for our other air dry products. It does well in cyclical offshore testing, and really it's superior to the air dry solvent-based finishes in just about every test that we've done. It also does well in mild to medium chemical environments. So you can see on this page, this is off the back of the technical data sheet, down the center aisle there, how well it does, either excellent or very good to good in various acids. So the chemical resistance of this product leads us to recommend this. We didn't think we would have to with an air dry product. So these chemical environments we're talking about are usually in industry, and all of the testing that we've done, like I said, is on the technical data sheet, and it's superior to air dry solvent-based finishes. So the HereShield technology really is the performance leader now. It fights corrosion and is our leader in HVAC films, air dry films. It stops the corrosion cell, fights galvanic and formicary corrosion. It's the performance leader for us. It's sustainable, more robust for our changing environments. It meets the demands of your customers who are more demanding than ever, and has excellent return on investment. So here's a situation, some real world testing that we've done. This is the Ocean Reef Resort in Vero Beach, Florida. This has been out on a rooftop for 10 months. You can see in the picture on the left where it's right on the ocean. That's the ocean just past it. The middle picture shows the coils are standing up great, no corrosion at all. And on the right, you can see the entire copper and aluminum setup of the coil. So this is doing very well. We check it yearly. We also have a job that we've done testing in Vietnam. It's the Vietsof Petro Resort in the Vung Tau province. Again, if you look at this picture on the right, you'll see the ocean. This is right on the ocean. So really some of the most severe salt air environments. So the test was done with 3 different finishes. This is, it's been out on a job for, I believe it's 2 years now. These are pre-coated fins where a coating is applied to the top and the bottom of the fin, but the edges are not coated. It's the most cost-effective way to coat a coil. But again, the edges are not coated. So you can see this just after, I believe this is a year, that it's starting to corrode. Also, this is a product which is a very thin film, translucent product out of Australia. And it's in a blue color. And you can notice on this as well that there's premature failure happening after a short period of time. This is our HereShield product. And you can notice the difference. This is their water-based finish I just talked about. You can see the significant difference in performance from the first 2 real-world tests that we're doing out there on that top of that building. So that's the story on our HereShield products and on Heresite products in general. If you have any questions, any comments, please feel free to reach out to me. On the screen, it shows my contact information. I appreciate your time. Have a great day.
At this time, we would welcome any questions into the chat. The first question we have is, who do we have on the East Coast that would perform the baking process?
So in upstate New York, we've got one of our certified applicators called Sandman's RCD. So Sandman's is in the Finger Lakes area, but they take care of the whole East Coast for us and some of the Southeast. They are available. Their contact information is available on our website. You can get on there and see Sandman's RCD, and they can help you as well.
Another question came in. For air dry systems, in an application where thickness is not an issue, for example, a chemical exhaust duct, can you increase the coat thickness and or number of coats to compensate for the lesser performing, or is it just going to peel off?
Like I said in the presentation, these are thin film coatings, so they're made to go on thin. So you can build this up and put more coating on there, but you may want to consider a conventional coating that's a primer finish system. If heat exchange is not an issue, you probably want to use a conventional coating system.
Another question, can coating be applied to systems already in the field or just new equipment? And what would the cleaning process be?
So we don't recommend recoating coils, whether it's in the field or in a controlled environment. First of all, we can't ensure that they're clean as you can try to get them. It's very difficult to get something that's been out in the field to clean. Also, once we start building mill film thickness and putting more coating on, we're going to impact the heat transfer loss. So yes, coating's very important. We do have people that do recoat coils, but we don't recommend it for those reasons.
Raymond is asking if anyone is close to PA.
Yeah, so Pennsylvania, Sandman's is not far from them. So Sandman's RCD will help anybody in Pennsylvania.
Will air dry coatings adhere to plastic components, particularly polyurethane?
Yes, they will. If you have overspray or you've got a component in amongst the copper and the aluminum, it will adhere to that.
What's the latest on coating aluminum microchannel coils, and are there best practice or are there best products from Heresite?
You can use the products that I talked about here. It's important to note that there are some inherent issues with coating MCHX coils. First of all, it's hard to get the atomized paint that you're spraying into the center of the coil. So if you have more than 2 or 3 rows, it's going to be difficult to get that paint into the center of them because the openings to get the paint in there are really smaller. The other thing we found is just the natural design of that coil makes it more conducive to corrosion. So it just holds corrosion more and holds chemicals and salt air more than a fin tube coil.
How people are wondering where they find the chemical resistant chart for the new HeraShield.
So it can be found on the back of the TDS. So you can download the TDS, the technical data sheet, or you can find our chemical resistance guide on our website.
Are there any restrictions on coil depth or fin density that would impact the performance?
Again, in spraying a coil, getting the paint to the center of the coil can be challenging. So if you're doing immersion or flow coating, there's not an issue with even a 10-row coil. But the thicker the coil gets, the more rows they are. Getting past 3 rows can be very difficult when you're using one of our air dry spray coatings.
Is this product available in spray cans?
Yeah, so the VR514, which is the air dry phenolic coating, is available in spray. It's used mostly for touch-up, for people that use our VR514 in production, or they use our P413, but it is available in spray.
It looks like we have one last question here. Can HereShield be installed by any painting company that has spray capabilities?
Yes, it can. First of all, our technical data sheet is very detailed for the settings on a spray gun and the proper method in spraying the coating. If somebody sprayed paint before, they can look at that and get a pretty good idea on how to put it on. The other thing that I would offer is if I have a conversation with them along with the TDS, answer their questions and point out just some little details in doing the spraying, it can be helpful. So we've taken people who spray other things that are proficient in spraying and taught them how to spray HVAC guar coatings. I think that's it. Thank you, everybody, for your questions. I appreciate it. Jeff, back to you.
All right, well, that concludes our presentation this afternoon. As Dan said, if you have any specific questions that didn't get answered this afternoon, please reach out to Dan directly. His contact information is still up on the screen. We will be sending out a copy of the recording to everyone that participated this afternoon, so you can feel free to share that with your teams. And we'll also send you a copy of the actual presentation as well. So with that, we'd like to thank everyone again for joining us this afternoon, and we hope you have a great day.
Thank you.